how the solution works so you get an idea of some of the things that will be expected of the program. I'm just here in the book I call it abuse, but over here it's called solution. So I'll just run the solution for now. If we run it like normal, it's going to create 3 insults. So I can change that by changing the number of insults to 2, and it will create 2 insults. I can also change, and the short flag for that is -n for the number of insults. I can vary the number of adjectives to say 3. And it will then say, you corrupt, foolish, ruinous fishmonger. And the short flag for that is -a, make it 4. But each time, and I'm sure that as you're running this at home, you're going to see a different set of insults. So we can control that with the -s flag. So I'll -s of 1. And each time I run that, I should get exactly the same output, exactly the same adjectives and noun, the exact same insults in the same order. I should always get that. And you should be able to get the same thing if you run that on your computer. And that's the short flag, and the long flag is --seed1. So that is what it means to be using a random seed. So we're going to have to learn how to incorporate that seed value from the command line into our program's logic so that our program can also create dependable output. With no arguments whatsoever, it should just do something useful. And now this is different. I don't believe we've written a program yet that doesn't require any arguments, any input whatsoever. And so we have defined defaults for all of these different options that we have so that it's not necessary to run with any input from the user. So we're going to talk about how to create all these options and have them have reasonable default values. So if but the program still will respond to -h for the help, and so we have some sort of a description. We're supposed to heap abuse upon our user. We see here that the number of adjectives defaults to 2, the number of insults defaults to 3, and the random seed defaults to none because we want to use nothing unless the user has defined something. If we look at our string diagram, we can see it written out like this. There will be some number of adjectives, some number of insults, and some seed, but all of these are optional. And the output of the program is going to be some number of insults. So we see here, if we run it with no inputs, we're going to get some random insults thrown at us. But if we say adjectives 1 and number of 2, we're going to get 2 insults that each incorporate just 1 adjective. So let's talk about how we can validate our arguments. For instance, we see here that if I try to run within of foo, that should not run. Foo is not a valid integer value. So that's something that we haven't done yet to this point. All of our inputs have been strings or possibly the name of a file. And so this is the first time that we're encountering the fact that the arguments coming from the command line are strings, and it's up to our program to convert those to numbers. And we can never assume that we're going to get valid values from the user. We should always expect that every single value is wrong, and we have to guard against that. It's going to be the same for our -a, the number of adjectives. If we say foo for that, we should also see that the program stops. It won't even try to run. It sees that that's not a valid integer value and just stops right away. So we're going to have to figure out how to do that. Another problem that we might encounter is, what if we are given, say, 0 as the number of adjectives? That should not be possible either. In this program's logic, we want there to be at least 1 adjective. So how can we verify that the number of adjectives is greater than 0? And again, it's going to be the same for the n, for the number. We don't want to produce 0 insults. We want to produce at least 1. We could produce 100. We're not going to put an upper limit on it, but there is going to be a lower limit. So those are some of the things that we're going to have to learn how to do as far as validating our arguments. So here I'm just showing you that there is in the test, I'm showing you that I'm in the test.py, there is a test called bad adjective number. And what I do here, and I pointed out, I'm making a random choice of some negative number between between -10 and 0. And I'm pointing this out because we're going to use random choice in our program to randomly choose a noun from a list. Range, the range operator, we can just take that code and go into Python. And if I run this, it's going to just say range -10, 0. In order to actually see the values, I'm going to coerce it to a list. And this is the list of options that is going to be chosen from. And in order to use the random choice, I have to import random. And if I say now random choice from that list, it chooses -8, chooses -4, chooses -1. So each time this the test runs, it's going to randomly choose some negative number. And then I run the program with that negative number, and I expect to see that the return value from the program, RV, return value, is some number not 0. So in the command line world, a program's normal exit value is 0, which to me I think of 0 errors. Anything that's not a 0 indicates that there was an error running the program, and so that it indicates to the operating system as a whole that there was a problem running this, and that could be very, very useful. We'll talk about it down the line. And then I'm looking also at the output that comes from the command line that I want to assert that that return value is not 0 when I run this with a negative value. And I also want to assert that the error message looks like adjectives and then repeating back to me what the bad value is, and then it must be greater than 0. So this is what the test is looking for. It's looking for the fact that your program detects an invalid adjective or number value, that it will exit with a non-zero status, and that it will create a very informative error message for the user. So these are some of the things that we're going to learn how to do. I encourage you to look at the manually checking arguments section that's in the argparse appendix. And there we're going to talk where I introduce the parser error function. And this will do 4 things for you. It will print a short usage statement, which is the kind of statement that we see. Well, I can't actually run this. This is the longer one. But it will print a short statement. Actually, I'm sorry. I can do it if I do a negative number. It produces this short usage statement. It will print the error message here, the error message, error -- number -1 must be greater than 0. It will stop execution of the program, and then will also exit with a non-zero exit value to indicate to the operating system that there was an error. So in order to do that, I show here that we looked at this a little bit, I believe, in the howler, because the input could either be plain text from the user or that text could indicate a input file. And I showed you how to intercept the arguments from parse args, and then to do something with, say, the args.txt. Here, I'm going to this is inside the get args, I'm going to intercept the arguments, and I'm going to say if the adjectives is less than 1, I can use parser error here to create an error. So the thing that parser error wants is the string, the error string that it's going to print out. And so if I call parser error with this error string, it will do all 4 of these things up here. It will print a short message, a short usage. It will print that error message. It will then stop execution of the program and exit the program with a non-zero exit value. So you're going to be using that in your get args as you write your program. We'll talk about more about importing the random module in the next video.